Let's go to LeetCode 1547, minimum cost to cut a stick. They give us integer n. That means this stick's length. And the cut I, that is the position you could perform a cut at. So we need to cut uh, operate those cuts to cut all of the cuts you in this cut array. And one cut, the cost is the length of the stick to be cut. So we want to return the minimal total cost of cuts. So let's look at the example. N equals 7. So that is from 0 to 7. And so let's say we have the first cut at 1, right? So the cost of the stick to cut is its length, right? The first cut cost is 7. So now we select um, 3. Um, if we collect 3, right? 3, then what we cut is this length, right? This length is 6. And then we cut 4, right? What we cut is this stick, right? This stick is 4. And then we cut 5. 5, what we have is this stick, right? This stick is 3. So yeah, so let's look at the total cost. This total cost will be 20. It is not optimal. So optimal way, what we want is we cut in this order, 3, 5, 1, 4. So what we cut first is at this one, right? This cut. So we have cost as 7. And then we cut a 5. Now we are cutting this stick. So that will be 4, right? Plus 4. Then cut 1. This one is also 4, plus 4. And then we cut 4, right? So what we left is this stick, is plus 2, right? This is 3, sorry, this is 3. Okay, this stick is 3. So the optimal cut, the cost is 16. So it asks what kind of order. It's not asking the order we cut, but the thing is asking the minimal cost. So let's look at how can we handle this question, right? We'll say for those cuts, what we want, for example, if we have the cut index I and cut index J, right? How can we get the minimal cost, right, of if we cut all of the sticks inside I and J, right? So we know if there are several cuts inside this one, right? There must have some optimal orders, and we can consider so the last step, right? It will always add this cost, right? J minus I plus 1. And but the thing is that we need to iterate what is the last cut, get an optimal last cut. So if we have K, right? So when K can iterate from I plus 1 to J minus 1, right? So then we'll see the cost of ij will be this one plus the minimal of ik and kj, right? So we'll iterate cik, ckj, right? And also plus this constant. So we'll say this is some kind of transition function. So we can intuitively thinking about use a dp to solve this problem, right? So dpij will be from the segment I to j. If we cut all of the cuts inside an I and j, what's the minimum cost, right? So we'll see we have this kind of DP definitions and also these transition functions. So what will be the DP initial state, right? So we know for all of the DP I and I plus one, right? That is the minimal cut. We cannot cut anymore. Those costs will be zero. So that will be initial state. So what we need to return, right? We need to return like we don't have cut at 0 and n, right? So we need to consider the 0 as a cut as well and the n as a cut. So we can need to dp this 0 to the end, right? So what is this end? So is that, for example, this have a m size. We add a 0, cut 0, right, at the beginning, and cut n at the end, right? So this will be dp 0 to this end, right? So that is m plus 2, right? Because we add 0 cut. We can consider, virtually we can consider there is a cut at the 0 position and a cut at this end position, right? So in the end, what we return is this 0 and end, right? So if we have m equals this kind of length plus 2, right? So that dp 0 m minus 1. So this will be our concept. So let's write code for this. The thing is that these kind of cuts, they are not in order, right? So in order, we can iterate from to get a I and j, right? We need them to be ordered. Otherwise, you cannot do some reversed, right? So we can do from the minimal to go to the bigger range, right? So we can sort this cut first. And let's have int m equals this cut of the length plus 2, right? And we're going to have an cut array. We add a 0 and add a m at the beginning and at the end, right? So we'll say cut array 0 equals 0, right? And for int I equals 1, 0, 1, I smaller than m plus 1, minus 1, right? I plus plus. So we're going to have C array I equals cut I minus 1. And C array m minus 1 equals n, right? So we add the beginning and end consider that will be the cut, right? So then we are going to have the kind of dp equals new int m, right? We want to find the minimal, right? We can set all as every dp as infinity, but the thing is that this one, because we are calculate um, for one by one, right? So if we don't set, that is fine as well, right? So what we want is return dp 0 uh, m plus 1. So what does dpij mean, right? This is an option. So dpij will represent we cut all sticks in the range I and j, the minimal cost, right? So we know so we need to iterate the gaps, right? Of course we can also iterate the length from I to j, but iterate gaps is more intuitive. It's like index, right? So what we do is for int gap equals 2. So we don't need to have gap equals 1, right? So if, let's say if ij gap equals 1, right? Initial condition dpi I plus 1, right? This is at 0, right? So this will be the initial condition, right? Because for every stick, the adjacent cuts we cannot cut it to be smaller, and we don't need to have any inside cut anymore. So the cost is 0, right? So we are going to have gap equals 2, gap was smaller than m, gap plus plus, and then what we do is for int I equals 0, I plus gap smaller than m, I plus plus, right? So we're going to have int j equals I plus gap. Okay. So we're going to have uh we are going to iterate now because I and j they have gap greater or equal to 2, right? So there must have we need there must have cuts between I and j. So we are going to have we want to iterate those cuts k, right? So we are going to have for int k equals I plus 1 k smaller than j k plus plus, right? So we'll see um we can have a base variable. Base equals integer dot max value. So we'll say this best will be max dot main best and dpik plus dpk j, right? So in the end we get dpij equals best plus C array C array j minus C array I, right? This is cut. The length is just I think it's just the difference. Possibly I mentioned that the length a moment ago is I plus j plus 1 plus this is not correct. So uh this we can look at the cut 1 to 3 there. 1 to 3 the length is just 2, right? So it is just this one minus this. Um so I think do we need anything else? I think that will be the code. So in the end, we just need to return dp0 to m minus 1. Means we cut all of the cuts from this range, right? All of the sticks. Um, So we'll see the time complexity. So we have actually these two follow-ups. It is like uh, iterate ing, right? And we iterate the cut between ing. So there are three follow-ups. So here this is O n square cubic power 3 time complexity, right? And this thought, of course, this is thought is n log n, and so the total will be O n power 3 time complexity with O m. O time complexity will be O m power 3, right? And space will be O m power 2. Um, let's also write Python code for this. Um, so we'll have cut sort, right? And then we are going to have m equals length cuts plus 2, and C array equals this one multiplied by m, right? And for I in range from 1 to m minus 1, right? We're going to have C array I equals plus I minus 1, right? And also we need to have C array m minus 1 equals n. And we need a dp, right? dp equals this one multiplied by m for this one in range m, right? And we don't need to about the gap one, right? So we just gap one is the initial condition. That is, we have dp gap equals one. That is, I plus one is 0. So what we can iterate is gap in range from 2 to m, right? And for I in range from 0 to m minus g, right? Then what we do is j equals I plus gap. And we are going to have a best equals infinity float. And so for every k in range from I plus 1 to j, right? Then we're going to have best equals mean best dp I k plus dp k j. Right? So we're going to have dp I j will be C array j minus C array I plus best, right? So in the end, we just need to return dp 0 to m minus 1 float.